will proceed in maximization, minimization along a constraint. We are bringing back this topic, maximization, minimization along a particular constraint, because we are in series of whatever we have done, whatever the invention, whatever the things that we have brought that is not available in any of the book. That in calculus, what we did new, what we did simpler. Doing new is not a big deal if it is complex. So big deal is that it should be simpler. Lagrange multiplier. So this reason is understood to be the one of the most kind of innovative area, one of the area in calculus where the scope is infinite. That is maximization, minimization. Maximization, minimization also comes in commercial calculus. Now, idea is that like a company has profitability or productivity, whatever. A company has productivity, and productivity of a company depends upon two items. One item is A and one item is B. A company is a company is manufacturing. A company is manufacturing an item. Company is manufacturing one item. That item is getting sold in the market. Now that item is made through the product. Means company is manufacturing a product, and product is made up of two items. So two kind of raw material. Like someone is making bulb, then bulb is made up of tungsten wire and glass. There may be more other thing also. So similarly, a company is making a product, and product is constitute two raw material. One is A, one is B. Now A has quantity X. A has quantity X, X amount, whereas B has quantity Y amount. Like X has 10 kg, A has X kg, and Y and B has Y kg. Now productivity or profitability, whatever comes to the mind, productivity of the product equal to X to the power 2 by 3, Y to the power 1 by 3. Productivity equal to X to the power 2 by 3, Y to the power 1 by 3. Means productivity of the product depends more upon the item A, whose the quantity is X. Productivity of the product is dependent upon another item B, whose amount is Y. So x to the power 2 by 3, y to the power 1 by 3. That is the productivity. Means it depends upon x more than y. If item A has x amount, x to the power 2 by 3. If item B has y amount, then y to the power 1 by 3. If I multiply, it generates the productivity of the product. When this productivity will be maximum, or if constitute profitability, then when this profitability will be maximum, that is the question. Okay, maximum minimum. If productivity equal to x to the power 2 by 3, y to the power 2 by 3, then when this productivity will be maximum, that is the question. Now anyone would answer, productivity will be maximum when x is infinite, y is infinite, productivity will be maximum, or profitability will be maximum. But no, there is a constraint. There is a constraint. What is the constraint? Constraint is that x, now the net, if someone is purchasing item A in X amount, item B in Y amount, okay, now the item A has a price that is per amount, per unit, how much it costs. X is a net amount, or consider it is X unit he purchased, and B, Y unit he purchased. Per unit, how much it costs. Consider per unit it costs alpha. Then alpha into x plus beta into y. Beta is the cost for the item B. Beta into y. This much is the net cost of the raw material. This cost must not exceed 3. This cost must not exceed 3. 3 may be in a $3,000, $3 million, whatever it is. So alpha into x plus beta into y must not equal to less than equal to 3. That is the constraint. Now someone has to find maxima in productivity, that is x to the power 2 by 3, y to the power 1 by 3. If this is the productivity, x to the power 2 by 3, y to the power 1 by 3, if this is the equation of productivity, this productivity, when will it will attain maxima, provided that alpha x plus beta y must not exceed 3, because that is the money someone can spend buying the raw material. And then when the productivity would reach maximum, in that case, what is x and what is y? Now consider that someone is going, now consider I have a, I, okay, I'll talk about what is the current solution and what is the solution that we are proposing. Okay, there is a sharp difference in that. Now consider that y equal to sine x. There is independent, now profitability, right now profitability is x to the power 2 by 3, y to the power 1 by 3. Here independent components are 2, x and y, mind it. This is 3D. Knowingly, unknowingly, this problem lies in 3D. Productivity is nothing but z, fxy. Z equal to x to the power 2 by 3, y to the power 1 by 3. That is z. Now consider two dimensions. Y equal to fx, function over x. Y equal to sine x. Y equal to fx, y equal to sine x. When sine x would be maximum. Sine x would be maximum when x equal to pi by 2, x equal to pi by 2, and then x equal to 3 pi by 3, 3 pi by 2, and x will be 0, pi by 2, 0, minus 1. Okay, it will be maximum only at pi by 2, plus then 2 pi plus pi by 2, then 2 pi into 2 plus pi by 2. Similarly, in the negative direction also, these are the places x is maximum. What we are trying to do, whenever we tackle a problem, first we need to, that's why I say that if analysis of the problem takes 3 hours, when the question has to be solved in 3 hours, then do it. Don't solve it, that is okay, but analysis should be very strong. Based upon the analysis only, everything, design and solution and testing, everything now sits on top of analysis of the problem only. What is the problem here? Y equal to sine x, when y would be maximum, anyone would say check dy by dx. When dy by dx is 0, at that moment it would attain extrema. If it is extrema, then it can be checked that that extrema is maximum or minimum. Pick the maximum, all the local maxima, pick it. Try to get them, as there is no one global maxima here. All are local maxima here. Simple, right? What we are trying to do, dy by dx equal to 0. In that fashion, in calculus, we try to get I'm taking two dimensions. So in that way, how we find that it is maxima or minimum? Okay, so we are dy by dx means we are trying to differentiate along the x-axis unknowingly. What we are trying to find? Maxima. Maxima, when it will reach maxima. When it reach maxima. Now that is a question. If we spend more time in analysis, then then it gives more clear result. This is x-axis, and consider that this is sine wave. This is sine wave. Okay, this is origin. Now this is the sine wave. Now sine went like this and became maxima and came down. Oh, this is maxima. How you knew that this is maxima? Because it looks like maxima. It looks like maxima with respect to what? It looks like maxima with respect to x-axis. If this is the x-axis or this is the x-axis, if this is the x-axis, then it is going. At one point, it becomes parallel to the x-axis. Or if this is I vector, then this is also I vector only. Then it touches I vector and comes down. Boundary is I vector. Here, if it is going like this, one point come when it just touches the y vector, I vector, and then it comes down. Maximization and minimization we are trying to find with respect to line that is x-axis, knowingly, unknowingly. That's why we are doing dy by dx. dy by dx means when y, dy by dx means rate of change, means how much y would change per 1 unit change in the x direction. Or in other way, if I say dy by dx equal to 0, then we are trying to find y value. We are trying to find y value where the dy by dx, there is no change in y with respect to x is seen. dy by dx. dy by dx means change in y that is seen, change in y that is seen when there is 1 unit of change in x at any point x. dy by dx. dy by dx equal to 0 means if at that moment of the x, if I proceed little bit also, there is no change in y that is seen. That's why dy by dx is 0. If that is the case, then there is a curve goes up. At one point it reaches when there is no change in the y seen with respect to x-axis. That is where we say it is maxima or minimum. Okay, what we are trying to do? Then in that case, we are taking derivative along x-axis. dy by dx means change in y, directional derivative of fx or y along I vector. There is a terminology called directional derivative. If I say dy by dx, then it is directional derivative along x-axis. That is dy by dx. Dx by dy, directional derivative of x along y-axis. Directional derivative of a function along any axis or any vector, that is typically called directional derivative along a vector. That is a different mathematics at all. It's 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 one of the case in x-axis. So directional derivative is nothing but directional derivative along any axis. Okay, if suppose this is x-axis, this is x-axis, this is y-axis, this is x-axis, then this is any axis. Okay, if I have a function like this, if I have a function like this, this is I vector, this is j vector, this is u vector. Now, what about if this is fx, that is y? What about what about dy by du? We are not trying to find dy by dx. We are trying to find dy by di vector. I vector is along x-axis. What about dy by du? U is a vector along one direction. dy by du. This is called directional. This is called directional derivative. dy by du. Okay. Now we understood many things now, that derivative is not a straightforward derivative. Derivative is always along a line. What is dy by du? When we talk about dy by du, what is dy by du? If I have any unit vector u, if I take one point here, at any point u, at any point u, if I move 1 unit in this direction, 1 unit in this direction, not in x direction, in u direction, 1 unit if I move, in u direction, 1 unit if I move, then how much y is changing? dy by du. This one unit movement in along u axis, it can have x component, it can have y component. We are not bothering about that. So 1 unit change along the u vector brings how much unit change in y? dy by du, dy by dx. Okay, this is called directional derivative along any axis. Anyway, let's understand the problem again. Now, productivity of the company lies in x to the power 2 by 3 into y to the power 1 by 3, where x is the net amount or net quantity of item A and y is the net quantity of item B. Then productivity is x to the power 2 by 3, y to the power 1 by 3. Means productivity depends more on x, less on y. Now, item A per item is cost alpha dollar. Per item of B cost beta dollar. So alpha into x plus beta into y, it has some constraint, restriction. Net price of the raw material cannot go beyond 3, less than equal to 3. 3 can be $3 million or whatever. If that is the scenario, then alpha x plus beta y equal to 3, less than equal to 3. We can now, this is the constraint. In this constraint, when this productivity x to the power 2 by 3, y to the power 1 by 3 will be maximum. Now let's draw it. Why to run away? Let's draw it. This is 3D, where productivity is z and x and y is xy plane. Now consider this is xy plane. Consider this is xy plane. Consider this is xy plane. Now if I take any value of x and any value of y, any point x comma y, then there is a vertical point called P, x to the power 2 by 3, y to the power 1 by 3. These explanations are not available anywhere else. Please support us. +91 is the India country code. 94831 60610. +91 is the India country code. 94831 60610. +91 is the India country code. Anyway, now this is xy plane and I pick many x comma y point. Depending upon the x comma y with the function fxy, the value is x to the power 2 by 3, y to the power 1 by 3. So I get z value somewhere in the space. If I connect, I get the productivity surface. Now this productivity surface would be, for this equation, at x equal to 0, y equal to 0, it is at the 0 point only. And after that, it starts growing, keep on growing. If I grow in the x direction, y direction. Okay. If x is negative, y is negative. That we don't take. So only first quadrant I have to take. If there are 4 quadrants, when x is positive, this is x-axis, this is y-axis. So this is xy plane. So x has to be positive, y has to be positive. None of them can be negative. So only first quadrant we are taking. Second, third, fourth. This quadrant we are not taking at all. Okay. In that scenario, if we are not taking those quadrants, then okay. So in that scenario, now question arises is that what would be the diagram? Someone can draw it, 3D diagram. But from here, it will start and it will go like a mountain, means up, and it will go up only as x and y is increasing. Okay. In that scenario, now we take contour at any fixed height. What would be the set of x and y on the xy plane? Okay. Consider the height is 1. At that moment, x to the power 2 by 3, x to the power 2 by 3 into y to the power 1 by 3 equal to 1. If that is the case, then we can draw it. On 2D, on xy plane, I can draw the set of xy point for which its value x to the power 2 by 3, y to the power 1 by 3 will be 1. Someone can draw a curve, okay? It will draw x to the power 2 by 3, y equal to x to the power, if it is 1, then y equal to x to the power minus 2 by 3. If I make q, then y equal to x to the power minus 2, 1 by x square, 1 by 1 by x square. So that is equation of y. So for any value of x, y, it will draw a line. It will draw a contour line. Okay, it draws a contour line. If I for fixed value 1, x and y would start differ, and so that value will be 1. Similar, like if I have x square plus y square equal to 1, that is a circle. If I keep drawing all the points for which x and y would satisfy equal to 1, it will draw a circle perimeter. Similarly, x to the power 2 by 3, y to the power 1 by 3 equal to 1, if I draw, it will draw some kind of curve. Okay, this curve, all the points in the curve must not go. Now I am drawing a line x plus, now the constant is alpha x plus beta y equal to 3. Alpha and beta consider $1. They cost $1 per unit. So alpha plus x plus y equal to 3, less than equal to 3. If I take maximum, then x plus y equal to 3. X plus y equal to 3 is a line. So if I have this as x-axis, this is y-axis, then xy3 will be a slant line like this. Okay, this is x-axis and this is y-axis. Then x plus y equal to 3 will be like this, where it will intercept x-axis at 3, 0. It will intercept y at 0, 3. Now, if I draw a contour, I know that when x and y keep growing, it's not like a sinusoidal. If I increase x, it becomes maximum. If I keep increasing, it go down. If I keep increasing, sin x become negative. It's not like that. If I keep increasing x and y, it will keep increasing. So this is easy for me now. In that situation, when x to the power 2 by 3 and y to the power 1 by 3 equal to 1, it will have one kind of a curve. Now, if this is the x plus y equal to 3, then there will be a curve something like this. This curve must, all point in the curve must not exceed this line. If it exceeds, go beyond this line, this is not the z value we are looking. Now we have to come down. Okay, come down till the curve come inside this line. If it comes inside the line, this is not we are looking. It should be more, because we are looking for more productivity. Then what you want? We want, if this is the x plus y equal to 3 is the constraint, and this is the curve called x to the power 2 by 3, y to the power 1 by 3 equal to 1. Let's try little more. Let's try little more. Go till it touches, just touches this line. If you go beyond it, then it will cross the line. Okay, we don't want crossing the line. We don't want minimum also. We want a point where it is touching it. At that point, this is maxima. How you can say this is maxima? This is what you are doing. Y equal to sine x. Y equal to sine x. If that is the case, then if you grow, sine x curve is like this. Okay, sine x curve is like this. Sine x curve is like this. Now, if I go along x-axis more, y would start growing. Okay, till it is hitting. Consider here I have a constraint line. Till hitting, it is hitting the constraint line. Then it is coming back. This is the maximum when it hits the constraint line like a tangent. Consider that constraint line is here. Consider the constraint line is here, and sine wave goes like this. What would be maximum? Then here, then if someone gives me possibility that I can increase the sin x like 2 into 2 into sin x. I can go multiplying by some factor. If this is sin x, then 2 into sin x will go like this, more till it is touching it. That is the maximum I can tweak it. Sin k into sin x. Now I introduce a function k into sin x. Now sin x maximum it can go pi by maximum it can go one value. But the line I am drawing parallel to x-axis, this is at height 3. Then I say k sin x, k 1, 2, 3. At the 3, it will start touching this line. If I go more, it will cross this line. This is not I want. I want maximization when it reaches 3. Similar to that, if I have x-axis and y-axis, there is a constraint line like this. I start drawing contour. X to the power 2 by 3, y to the power 1 by 3 equal to 1, equal to 2, equal to 3. And there it will draw a curve. The curve which is just touching this x plus y equal to 3, there x and y we have to find, because that whole x square, x to the power 2 by 3, y to the power 1 by 3 is maximum. Actually, x to the power 2 by 3, 1, y to the power 1 by 3, 1 by 3, it is 3D, not 2D. Where x to the power 1 by 3, y by 3, it results in 3D. But it will keep on growing, okay? But we cannot take x and y growing like this. X and y, what we take, so if this is x-axis and this is y-axis, then x and y, what we are taking, which is keep on growing like this, then x and y, this is, in my diagram, this is x plus y less than equal to 3. X and y, I have to select below this only. I cannot go cross the boundary. If that is that, now one is on xy plane and one is 3D. How we can find it? Then I have to cut this 3D into contours, and one by one I draw contour on the xy plane and check it. So now in that case, when x and y just touches this x and y, the contour, if touches this line, at that point it is maxima. This is one scenario. Other scenario can be, in our case, it is climbing up if I increase x and y. Sinusoidal, not sine. Sinusoidal, if it is sinusoidal 3D, it is something like that, then it will go beyond some point and it will be reach maxima and it will come down. So, okay, when it come down, at that moment, it will touch x plus y equal to 3. There is a 3D which goes up, and it comes down. While it is coming down, at that moment, if I take x and y value, there it is touching x plus y equal to 3. Certainly, that is not the maxima. Maxima is behind that only. When is the maxima? Okay, when is the maxima? That is the question that is arising. When is the maxima? Okay, now scenario is that when is the maxima, what we are trying to find. Okay, anyway. Now, what Mr. Lagrange is saying? Mr. Lagrange is saying that in this particular scenario, if I keep increasing x and y, if I keep increasing x and y, then productivity or z value fxy keep increasing. When at a moment it will touch x plus y equal to 3 line. When it touches that line, at that point, if I calculate the gradient, if there is a curve, and if I calculate the gradient will be perpendicular to the curve. Like if I have a circle x square plus y square equal to a square, if I calculate the gradient vector, that is xi plus yj, if there is a circle, if there is a circle, it is centered at origin, and if I take gradient, that is 2x square plus y square equal to a square, the gradient is 2xi plus 2yj. The gradient will be tangent at every point. Okay, now I have a constraint line. For this constraint line, if I calculate the gradient, again it will be tangent to this line. When this x to the power 2 by 3 and y into y to the power 1 by 3, when it is touching the the constraint line, at that point, this gradient, that is this, and this line's gradient, that is also this, they will be in same direction. Once gradient, because this x to the power 2 by 3 into y to the power 1 by 3 for a particular contour, for a particular height, I can draw it on xy plane. If I draw in on xy plane, means set of xy point for which it meets the height, a particular height like 1, 2, 3. If I say x to the power 2 by 3 into y to the power 1 by 3 equal to 3, then there are set of point x and y which would satisfy equal to 3. Those set of point, if I draw, it will be a curve line. That curve line, when it is touching, when it is just touching x plus y equal to 3, at that moment gradient vector of the curve line will be like this, and gradient vector of this x will be, both will be in the same direction. This is what Mr. Taylor is saying. In that sense, the gradient vector of the x to the power, consider x to the power 2 by 3 into y to the power 1 by 3, gradient vector is g, and constraint line gradient vector is h, then g equal to lambda into h. This is what he is saying. Since they are in same direction, I can say both vectors are same. Since magnitude different, to settle down the magnitude, I will multiply with the lambda. This is called Lagrange multiplier. So g, that is gradient vector of the productivity, equal to lambda into gradient vector of the x plus y less than equal to 3 or equal to 3. Okay, now let's try to find out through the Mr. Lagrange way only. If that is the case, then gradient vector of x to the power 2 by 3 into y to the power 1 by 3, first I have to derive with the x, then it becomes 2 by 3 x to the power minus 1 by 3 y to the power 1 by 3 I plus 1 by 3 x to the power 2 by 3 y to the power minus 2 by 3 j. This is the gradient vector for the productivity. Gradient vector for x plus y equal to 3 is I plus j. Simple I plus j. That is the gradient to this. Then 2 by 3. Then 2 by 3. 2 by 3 x to the power minus 1 by 3. 2 by 3 x to the power minus 1 by 3 y to the power 1 by 3 I plus 1 by 3 x to the power 2 by 3 y to the power minus 2 by 3 j equal to lambda I plus j. Okay. Now lambda both will, now if I satisfy this equation, then 2 by 3 x to the power minus 1 by 3 y to the power 1 by 3 equal to 1 by 3 x to the power 2 by 3 y to the power minus 1 by 3 minus 2 by 3. Now 3 cut down, 2 and 1, this side x to the power minus 1 by 3, it goes that side, it becomes x, and y it becomes by 2y equal to x. 2y equal to x. Now I have constant that 2x, constant that x plus y equal to 3. Now 2y equal to x equal to 2y, then it becomes y equal to 1. If y equal to 1, then x equal to 2. Y equal to 1, okay, 2y equal to x, then x equal to 2y. Now I have 2y plus y equal to 3, 3y, y equal to 1. If y equal to 1, then x equal to 2. Okay, so it attains maximum when x equal to 2 and y equal to 1. This is what Lagrange is saying. I believe we can stop here and we will proceed on it. So this is the Lagrange way. This is completely incomplete, unfortunately. He is actually not addressing the problem at all. This is the bad thing about it. What someone is trying to achieve, with this problem, with this solution, is something weird. It looks like rather than analyzing the problem, he is jumping on the solution. Since it is the gradient vector is parallel to each other, then he goes for multiplier. What is the solution? Actual solution, what we are trying to find out. If I have contour lines, if I have contour curve, then we are trying to find the maximization in the contour with respect to a line that is x plus y equal to 3. If I have equation like y equal to sine x, we are trying to find out, or y equal to k sine x, we are trying to find out maximization along x-axis. Here, maximization along x plus y equal to 3 line. Okay, what is the scenario? This is fit case of directional derivative. We a directional derivative means if I have equation y equal to sine x, dy by dx equal to 0, means we are trying to say directional derivative of y along x-axis. When it is reaching 0, at that moment, this derivative is 0. At that moment, this y curve is just touching the I vector. At that moment, it is parallel to the I vector. This is what I can say, the tangent. If I x-axis, if I draw y, every moment I can have tangent. If I have y equal to fx, if this is x-axis and y equal to fx, then everywhere I have tangent. If it is sine x, y equal to sine x, everywhere I have tangent. Okay, when this tangent is parallel to the x-axis, I say it is maximum. Similar thing we are trying to do here, right? If I have x to the power 2 by 3 and y to the power 1 by 3, if that is the equation, then there is a line called x plus y equal to 3. This line is growing and there is a tangent. One moment comes when the tangent is parallel to the x plus y equal to 3. X plus y equal to 3, if I talk in a vector, then this is directional derivative along a vector. That is dy by d vector. Dy by d vector direction, if it becomes 0, there we are reaching the maximum. So first we have to find the directional derivative of this kind of the contour, what we are trying, the directional derivative of the contour along the x plus y equal to 3 line. Earlier we were trying along x-axis means y equal to 0, or in a vector term along I vector. What I need to do now, we are trying to find the maximization along a particular line, not along x-axis. In normal case, if I do dy by dx or dfxy by dxy plane in 3D, we are trying to find maximization along xy plane or along x-axis. Here we are trying to find maximization along any axis. What is that axis? That axis is nothing but a line. What is that line? That is x plus y equal to 3. Along that line, we are trying to find the maximization for the curve x to the power 2 by 3, y to the power 1 by 3. Now I have to, if that is the case, then directional derivative along any vector v is nothing but gradient of the algebraic equation. Whatever algebraic equation we have, gradient of that dot product with the unit vector along the direction against which we are trying to find the directional derivative. So this is the solution we have proposed, because this exactly matching the problem. We are trying to find maximization, minimization along a certain direction, not along x-axis. He is trying to find along x-axis only. And for that, he is trying to do for both along x-axis and satisfying it with lambda. Lambda is not required at all. If you use lambda, then if you read in the book, then there are further explanation about the lambda Lagrange is doing. What is lambda? And then I believe he comes up with a Lagrange function also. Lagrange function also. Many complex. If you don't go exactly hitting the problem, don't understand the problem exactly, then you will have n number of things in the future. So idea is to constrict the problem to the minimum reason so that someone can tackle it quickly. If you introduce new variable lambda and this and that, then problem will expand. Try to minimize the thing so that problem will come to a smaller area. That we will see through the directional derivative along a particular direction. Please support us. This is our solution. Please do support us. Plus 91 is India country code 94831 60610. 94831 60610. 10 plus 91 is India country code.